You know, we often think of AI as something that just sees the world and reacts. But what happens when an AI needs to think ahead? Today, we're going to dive into the mechanics of problem-solving agents. These are AIs that don't just react, but actually plan for the future. They set a goal, and then they figure out the precise steps to get there. So you've really got two different flavors of agents here. On one hand, you have the simple reflex agent. It sees something, and it acts. Stimulus leads directly to response. Pretty basic. But on the other hand, you have the goal-based agent, and this is where things get really interesting. This agent considers the future. It has a goal, and it forms a plan to reach that goal. The crucial difference, the secret sauce, is foresight. So how on earth does an AI build that kind of foresight from scratch?
Okay, here's our game plan to figure that out. First, we're going to look at the agent's master plan, which is the basic cycle all these agents follow. Then, we'll get into how they build a mental map of their world. After that, we'll explore a really clever trick they use to handle complexity, what I'm calling the art of ignoring detail. And finally, we'll see how they put it all together and actually execute the plan with confidence.
All right, so at the very heart of any of these planning agents is this master plan. It's a reliable, repeatable process that they all use. This isn't just guesswork. It's a very structured, four-phase cycle that takes them from just having a goal to actually taking action.
So, it all kicks off with goal formulation. Super simple. What does done actually look like? What's the target? Next up is problem formulation. This is where the agent defines all the possible states it can be in and all the actions it can take. It's basically creating a map of its world. Then comes the search phase. This is the cool part. The agent mentally simulates different paths on its map, looking for the best way to get to the goal. And finally, execution. Once it finds that best path, it carries out those actions in the real world.
Now that second step, problem formulation, that is where the magic really happens. This is the agent building its mental map. See, before an AI can search for anything, it has to translate a messy, real-world problem into a perfectly structured, formal description that a computer can actually understand and work with. And that formal structure has a name. It's called a well-defined problem. Think of it like a recipe the AI uses to build its map. And for that map to be any good, for it to be something the AI can actually navigate, the recipe needs these 5 key ingredients.
This table is awesome because it lays it all out perfectly. Let's use this road trip example, getting from Arad to Bucharest. First, you need the initial state. Where are we starting? Easy, we're in Arad. Second, what are the possible actions? Well, you can go city. Third, you need a transition model. This is the rule book. It says, if you're in this state and you do this action, here's the result. So if you're in Arad and you go Sibiu, the result is you're now in Sibiu. Fourth is the goal test, the are we there yet function? It just checks, is our current state in Bucharest? And finally, number 5, the path cost. This one's absolutely crucial. It assigns a cost to each step, like the distance between cities, so we can find the best way to get there.
And that right there is the whole point. The agent isn't just trying to find any path. No, it's looking for the optimal one. Using that path cost, it's hunting for the sequence of actions that gets it to the goal with the lowest possible cost, whether that cost is the shortest distance, the fastest time, or maybe the least amount of fuel used.
Okay, so the problem is defined, the agent has its map, but there's a huge problem. The real world is just messy. It's infinitely complex. If an AI had to think about every single tiny detail, how could it ever get anything done?
Exactly. I mean, just imagine if our driving agent had to plan for every single tiny turn of the steering wheel, every little change in pressure on the gas pedal, every gust of wind. It would be totally paralyzed by the data. It would never finish calculating. The solution, and honestly, this is a cornerstone of intelligence, is abstraction. It's the art of simplifying things.
So what is abstraction? Well, it's not about being inaccurate or wrong. It's about being smart and strategic. Abstraction is simply the process of stripping away all the unnecessary details, all the noise, so the agent can focus only on what's absolutely essential to find a solution.
And this slide just nails it. Instead of planning for thousands of little micro-actions, the agent thinks on a higher level. It plans with one single abstract action, drive to Sibiu. It ignores all the nitty-gritty details, and by doing that, it turns an impossibly complicated problem into one that's actually solvable.
Okay, quick recap. Our agent has a goal, it's got its map of the world, and it has a simplified, abstract plan. So what's left? Well, the final step in the cycle is to actually go out and act on that plan. Now, this standard model uses something called an open-loop system. And what that means is, once the search is done and the plan is set, the agent just goes. It executes the whole sequence without taking in any new information. It basically closes its eyes and trusts that its internal map is perfect and the world isn't going to throw any curveballs.
This close your eyes and go strategy works amazingly well if the world is predictable and doesn't change. Think about a game of chess. The board stays the same. But for a real road trip, you could hit a traffic jam, a road could be closed. That's where this assumption gets a little fragile. For those unpredictable environments, you need a more advanced closed-loop system, one that actually looks at the world after each step to see if the plan is still good.
So let's pull all these threads together. The whole secret to AI problem solving is taking the messy, complex, real world and abstracting it into this formal structure. This structured map, this graph of all possible states and the actions that connect them is called a state space. And once you've represented the world as a state space, you can unleash powerful search algorithms to find the absolute best path from your start to your goal.
This entire framework is incredibly powerful, but its greatest strength is also its biggest weakness. It's all built on the assumption that the world is predictable. And that leaves us with a really big, fascinating question. How does an AI adapt when its perfect abstract plan smacks right into a messy, unpredictable reality? That, my friends, is the next big challenge in building truly intelligent agents.